1 or 2, it's like it takes off. So exponential growth is very, very rapid growth. All right? How are we doing on time? Got 15 minutes. All right, so in general, exponential functions look like this. Okay, so I've given you all these different forms of functions. Like lines look like mx plus b. Quadratics were ax squared plus bx plus c. Polynomials, remember that subscript that I used for polynomials, x to the n minus 1, all that, and you hated it? Okay, and then rational functions was polynomial divided by polynomial. Exponential functions are very, very clean as far as when you look at them. It's just some number, which we call the base. So that's why we're using b there, raised to your variable, x. Now there are some conditions on that base. The base has to be a positive number. And the base cannot be 1. Why not 1? So if you take 1 and raise it to any power, it's just 1. 1 squared, 1 cubed. So it wouldn't do anything. It would be boring. It would be very uninteresting. So that's why we throw that out. And positive numbers, only positive numbers, because when you square negative numbers and cube negative numbers, weird things happen. So we just throw those out. All right, so let's do one more example of an exponential function, and let's try and graph it. Graphing these is actually pretty straightforward. Let's graph f of x equals 5 to the x. And then over here, we're going to do another problem. We're going to graph f of x equals 1/5 to the x. I don't think you're in the position in this class to be doing that. I really don't. I'm not sure what you're doing, but yeah, okay. I see a lot of people on their phones. I've been very laxed about it, but please respect the rules in the class. The rules are no computers or phones, or you lose 10 points on your next test and you're asked to leave. Do y'all remember that? That's the rule. If you read the syllabus, that's what it says. Now, I've been very laid back about it, but it's getting a little bit out of control. All right, graphing these two. Now, we have a process for graphing lines, parabolas, polynomials, and rational functions. We're not graphing, right? These, all we're going to do are t-tables. That's it. We're going to make a t-table like old school, plug in points, and draw it. All right, that's what we're going to do. So the t-table that we're going to make, we're going to plug in x here, do 5 to the x here. This is our x, this is our y. I want everybody plugging in the same numbers. Everyone's going to plug in the exact same thing into their table. That way we all get the same picture. So what I want to do is plug in various values into this. I want us to plug in 0, 1, 2, and 3. But then I also want us to do -1, -2, and -3. So here's the way it should look when we write it. -3, -2, -1, 0, 1, 2, and 3. So I want us plugging in a total of 7 numbers. Are y'all familiar with t-table? Yes? This is like the first way you learn how to graph stuff. It's very basic. But it works for these. All right, it's enough for us to be able to do these. All right, this first one, I'm going to plug -3 in. 5 to the -3. So what is 5 to the -3? So how are you getting that? You're typing it on your calculator? Okay. Properties of exponents. Do you all remember that if you ever have anything to a negative power, it's the same as 1 over that to the positive power. So you're often told in school, like if you see a negative power, you drop it down. Do you all remember hearing something like that? So what I'm going to do is I'm going to rewrite this 5 to the negative 3 as 1 over 5 cubed. That's the same thing. Now 5 cubed is 5 times 5 times 5, which is 125. So this is 1 over 125, which on your calculator is like 0.00 something, right? That's a very small number. It's a positive number though, right? Okay, how about negative 2? 5 to the negative 2 is 1 over 5 squared, which is 1 over 25. That's still a small number. Right? 1 over 25 is small. It's not as small as 1 over 125 though. That's smaller. Bless you. Let it go. Let it go. 5 to the negative 1 is 1 over 5, which is just 1 over 5, 1/5, 0.2. Do y'all know what I'm doing here? Yeah? Okay. How about 0? 5 to the 0. Anything to the 0 is 1. Okay, so that's 1. And now we're going to plug in 1, 2, and 3. So 5 to the first power, 5 to the second power, 25, 5 to the third power, 125. See how these numbers are kind of related to each other? They're just the reciprocals. Like if I took that and flipped it, I get this one. If I take that and flip it, I get this one. If I take that and flip it, I get that one. So look, we're always going to use negative 3, negative 2, negative 1, 0, 1, 2, and 3. That way we all get the same graph, all right? There's consistency. So I'm ready to graph this. All right, let's try this. I want you to notice something about my graph already. I did not have anything, I didn't really leave my space, any space down here to go negative, did I? And that's because if you look at this table, our outputs, our y values were always positive, weren't they? So I'm not even ever getting a negative number out. Then I'm going to mark out 1, 2, 3, negative 1, negative 2, negative 3. How should I draw my y-axis? How should I label it? By 5s. What's the biggest y value I'm going to need? 125. Yeah, I can count by 5s. It might take me a while though. Count by 25s maybe? 25s? So we have like what? 25, 50, 75, 100, 125. Maybe I should have made those a little bit bigger, but that'll work, I guess, for now. And now start plugging in your points. Do all of you understand that this is the point negative 3, 1 over 125? Like that's the x and the y coordinate. The next point is negative 2, and then 1/25. And so on and so forth. Let's do the ones that are the easiest to graph right now. What do you think is the easiest point to graph on this entire thing? 3, 125? Think so? 3, 125? Because that one's pretty easy to see. It's right here, right? That one? How about 225? Is that pretty easy to put up there? Yes. 225 is about right here. 1, 5, right about in here. And now what's happening as I go that way? 0, 1, it's going to be hard to draw, right? Negative 1, 1/5. Negative 2, 1/25. Negative 3, 1 over 125. Very small, right? So what we have here is the graph is doing this. Is it ever going to touch that axis? No, it's never going to touch. So I'm going to draw a line like that. And then I'm also going to draw a dashed What is that called? A horizontal asymptote. See, it's just like with the rational functions. Only on one end, it's going towards that dotted line. It's never going to get there. Now, what is it going to do as I go this way? It's going to take off, right? That's the graph of that exponential function. Okay, we have another one, 1/5 to the x. I know you want to go. We've only got like, what, 3 minutes? I'm going to set up the table with you, though. The other one was 1/5 to the x. We're done here. That's the graph. X, 1/5 to the x, -3, -2, -1, 0, 1, 2, 3. Now this is going to be slightly interesting here, how you do this. When I plug in -3, I'm supposed to take 1/5 to the negative power. Does anybody know how to treat a fraction that's raised to a negative power? What you can do with it? Flip it. You flip the fraction over and you make it the positive power. That is a property of exponents. So we can flip this fraction, make it 5/1. What's 5/1? 5. That's equivalent to 5 cubed. What's 5 cubed? 125. Same thing here. 1/5 to the -2 would be 5 squared, which would be 25. So you flip it. The next one would be what? Just 5. What about the next one? Any number to the 0 is 1. So this is 1. All right, what about when you plug in 1 up here? What's 1/5 to the 1? Well, itself, right? Remember, anything to the 1 is itself, so we just get 1/5. What's 1/5? This times squared, because we're plugging in 2. What's 1/5 times 1/5? 1/25. Do these look familiar? Yes. The next one would be 1/5 cubed, which is 1/125. That's 1/5 times 1/5 times 1/5. You multiply straight across. Boy, this graph looks awfully familiar, doesn't it? I mean, kind of. What is it? What is it compared to the one that's up here? It's like the opposite, right? At -3, it's up here at 125. At -2, it's at 25. At -1, it's at 5. And this graph, as you move to the right, goes like this. And it has a horizontal asymptote that way. We call this exponential growth. We call this exponential decay. So growth, as you move from left to right, if you go up, that's exponential growth. If you move from left to right and go down towards 0, then you call it decay. Now for homework, I want you to do numbers. I'm going to change the homework assignment for this section a little bit. Page 103. And I want you to do numbers 4 and 6. And that's it from there. Let me just see if there's anything from 2-4 that I want to add to this polynomial rational function here. From page 93, I want you to look at 42, 43, and 46. And for those right there, find x-intercept, vertical asymptote, horizontal asymptote. I want this homework turned in next week. beginning of class. All right? Okay, this will force you to have to go factor, which means hopefully it'll force you to go get some help.
Just those 5 problems?
Yep, these 5 problems right here. On the page 103, this one right here, it says to graph it, and it tells you some additional information about graphing. Just use the table, just like this. Plug in -3, -2, -1, 0, 1, 2, 3 for both of these problems. All right, have a good weekend, everyone. All right? I'm a little stressed today.